so the next stuff starts out looking like this. We're going to talk about even and odds. Okay, so back in geometry, we learned about symmetry. And we learned about, let's see, they call it reflective. Reflective imagery, or symmetry, which means, you can flip it across either the X or the Y. But for us, it's going to be, I said that backwards. But us, it's going to be the Y. So we're going to be flipping it this way. And you notice it's the exact same, just on different sides of the Y-axis. That's symmetric with respect to the Y-axis. And then you also talked about rotational symmetry, which you may or may not have called that, but you rotated things like 90 degrees and 180 degrees and so on. So take your paper, like on G of X, so for this one right here, and take that and flip it upside down. And it looks exactly the same for G of X. That's this one in the middle here, this one. If I flip it upside down, it looks the same. That's rotational symmetry. It's by 180 degrees, which is what we're doing here. And so I want you to go through and write down whether these are symmetric by reflective or rotational properties. So we already said this one was reflective. This one's rotational, and you do the other four. So just think, can I fold it and it'll land on top of itself, or do I flip it and it's the exact same thing? It'll be one or the other for these. So Justin, what's H of X? Reflective. So if I fold it, does it land right on top of itself? No, because if it was reflective, then it would look like that. So it must be then what? Rotation. And the way to figure that out is if I flip that upside down, which if I flip this, it's not going to help us any. But if I take that and I flip it upside down, it looks exactly the same as it did. That's all you get to do. Yes. Kendrick, what about P of X? That's reflective. If I take this piece of paper and I folded it, it would look the same on both sides of the y-axis. It's like you put a mirror on the y-axis. Hazella, what about R of X? Yes, that's exactly the same as if I flipped it over, it would look the same. And then Q of X, Donna? Very good. It's the same on both sides of the y-axis. So I say that because that's how you figure out even and odd. The evens are reflective. The odd functions are rotational. A specific kind of reflective and a specific kind of rotational, but that's why we're going over these. Okay. So and I'm sorry that this is on the back page. So for like f of x, you're going to have to flip back and forth. What it wants us to do is it wants us to list all the points that are labeled from left to right on f of x. So notice f of x, that first point is -4, 1. So look at f of x and see that. No, mine is -4. Did you do the same? You. Oh! Just kidding. Oh no, you go all the way to the left. Find the first point on the left. What's the next point when I go to the right? The next point that has a dot on it. Tyler.
-2, -1.
Yes. Jose, what's the next point?
0, -3.
Yes. The next point, Shelby? Very good. And Cameron, the last point.
4, 1.
4, yep, 1. Okay, what was another reflective one? What was another one, Jenna? P of x, okay? And the other reflective was Q of x. So write down those points from left to right. Just the points that are dotted on this picture for you.
Like even the ones that started.
Yes, so like the first one for P of x would be -6, 4. There's a method to this madness. Check your points with mine. Make sure I didn't. Yeah. Let me know if you got something different. It's quite possible I threw a negative where it's or whatever. So if they are reflective with respect to the y-axis, so they're symmetric with respect to the y-axis, Is there something like if you look at f of x, or if you look at p of x, or q of x, is there something that you notice about the x's and or the y's?
They're the same number if its sign just changed.
Okay, which one, the x or the y? Or both?
The X.
Okay? So, like, for the points, she's saying if you have -4 and you have +4, notice the y's are the same. If you have -2 and +2, notice the y's are the same. And this is 0, so there's only one option here. Same thing here. -6, +6, they're both 4. Skip. -1, +1, they're both 3. Same thing here. -5, 5, they're both 4. -3, 3, they're both 0. -1, 1, they're both -2. These are called even functions. And always they are symmetric with respect to the y-axis. So I'm going to scroll down here. So even functions for each point to the left of the y-axis, there is a point to the right whose x-coordinate is opposite and y-coordinate is the same. That's just in words what we